go ahead after everything is done to the design part of this software. The design tab in MIDAS Gen. Here all I have to do is, the important part is, if you have secondary or tertiary beams, go ahead for the member assignment, so that if there is any division of primary beams, those can be considered as one single beam. So I'll click on member assignment right over here. Here I'll click on automatic, selection type will be all, and click on apply. So as you can see over here, I'll show for the last level. So I know that this primary beam has been divided into two. So this is taken as a single beam for designing by using this member assignment. After performing the member assignment, I'll go to the RC design, and here firstly I'll choose the design code. So I choose the design code as ACI 318M14 so that I get in metric system. I can apply the special provisions for seismic design, in which I can consider this as intermediate moment frame, and for boundary element I can select the boundary element method for boundary element design of the shear wall. It can be either of these two formulae. The second one is quite conservative. Then the shear for design can be taken as per the codes. Then further we can also apply the torsional design and the moment redistribution factor for the beam. I'll click on OK. Let me unselect. Further RC design, I'll go to the RC design and modify the concrete material. I'll click over here the grade C4000. After the analysis also I can change the material property of the elements. Now here this is an important part wherein I have to provide the reinforcement material property. So I'll select the code. So I'm using BSRC 460, and I'll say modify and close this dialog box. Again, I'll go to the RC design. After modify concrete material, the next thing important is design criteria for rebar. So here I'll have to select from the rebars. This is ASCM, however we need to choose from the BSEN to get to BSEN. I'll close this dialog box and this dialog box as well, and go to the tools and then preferences, to the design preferences basically, wherein I need to select the design code and the rebar material code, and I'll click on OK and get back to the design tab, RC design and design criteria for rebar. When I click over here to select the rebar diameters, I'll get the BSEN on for selecting the diameters. Now why am I selecting these diameters? I'm selecting these P12, P20, P25 diameters. I'll click on OK. Why am I selecting? The software MIDAS Gen basically provides you the not only the area of reinforcement but also the arrangement of the reinforcement along the section. For that, it will ask you the diameters available. So only a few diameters available on site, so you can select from those. For the main rebars as well as the sub rebars, that is the stirrups. So let me select P12, sidebars also as per the depth and arrangement. This is two-legged arrangement. Further is the effective cover. So this you can manually provide, or the software can automatically take the effective cover as per the chosen diameter for arrangement. This is for beam design. All the horizontal elements will be designed as beam. Then there are column design. All the vertical elements are designed as columns. So similar to beams, I'm going to provide the software with the diameters available for my column design. So I'll click on rebar. I'll select these three and I'll click on OK. Similarly, ties and spirals, I can change the diameter, and the arrangement also can be different. And also here is the effective cover for the column. This the software will automatically take. Let us go directly now to the shear wall design. Any of the inclined elements are designed as brace elements automatically unless we assign a member type as beam or column to that inclined member. So I'll skip that. We do not have any inclined member. I'll go directly to the shear wall design. Here I'll select the vertical rebars. So let me select P10, P12 and P16 and click on OK. So here again horizontal rebars I'll select as P12 and the edge rebars or the end rebars as P12 again. Then the effective covers at the edge and at the width can be taken by the software automatically. Further, in the input additional wall data, you can have the wall designed as out of plane bending. However, you need to have the wall element type as plate. In this workshop we have taken as membrane, so we'll not check this on. And click on OK. And OK again to close the dialog box. And this is it. All I have to do right now is go ahead and perform the concrete code design. So firstly I'll design the beam, column and then the walls. Does not matter. Anyway, let me perform a batch design of all these. So here I'll perform batch design of concrete beam design, column and wall. I'll click on run. Okay, so of walls. The software shows us the results by property and by members. Property meaning the section property has been assigned to n number of beams. So though out of those, whichever the critical beam section is there, for those the software provides the information right over here. Similarly over here for the beam 2 it's failing and intermediate. The software provides the check over here if it's okay or if it's failing, and if so then why. So this is failing because of axial and shear force. We can go also to the member over here, sorting by members, wherein the software will provide the detailed report or the detailed design information of each and every member. So I can click over here to see the graphic report. So this is the design result. This is mostly used for the reports, design reports. So we can save this as bitmap file. I'll close this. As well we can get the detailed report of each and every member. This is step-by-step report with each and every formulae as per the code and each and every check. You can compare this with your manual calculations. It just does not give you one particular information of how the software is going to design, but how the software has designed for each and every member. I'll close this text file. I can save this text file, use this text file for the reports. Now if I want to see any of the beams have failed out of these all the members, I can click over here. This is the entire table which provides the summary of the report of the design. I can copy this table and paste it in the Excel sheets. Okay. But right now I'm interested to know which beams have passed and which beams have failed. So here I can click on OK to see all the beams that have passed, and NG, that is not good, to see the beams that have failed. So these are all the beams that have failed. I can check on any of these beams and see the reason. So over here you can see that it has failed for the moment by 1.2. And here I can see that a lot of bars are required and it is failing for the moments, for negative as well as the positive moments. Okay, so it is failing in the shear, as we can see. So what we can do is, this is the preliminary dimensions of the beams. Even after the design, I can go ahead and change the section shape. I'll go to the section for design, beam, modify, and here let me increase it to 75, and I'll click on OK. Similarly, I'll do for beams 2. I'll make it 75. Increase this to 35 and click on OK. Intermediate beams, modify. I'll make this as 0.6 and I'll change this to 0.3 and click on OK. So after I've changed the section properties, I can go ahead and design and check if the design is passing for these modified sections. I'll close this dialog box. Now I want to design only for those which have failed. For that, I will connect these selections to the model view and I'll say select all. Okay, I'll close this dialog box, and if you can see over here, these are the beams which have failed, and I'll go ahead and perform design for these particular selected beams. So as we can see over here, all the beams are passing. That means I need to change the section shape. So by property, I can understand the most critical beam has also passed. I can go to the members and see all the members that have passed as well. And I can check on and see the graphics, how the results have been provided, and also check for the detailed report. So this is how I can get the beam design result. Now this is wall design. So the walls have failed, a few of the walls have failed. So I can check which walls have failed by going to the sorting by ID plus story. That means for each ID and each story separate wall, each and every separate wall, the design result is shown. So to check which of the walls have failed, I'll just unselect all of these and I can simply go to the full view, sort these not good ones, and I can connect to the model view and select these all. So as you can see over here, that the lowermost walls have failed. These are the all walls that have failed, the small ones. And to make changes over here for designing, I need to go back to the pre-analysis mode, make change in the thickness, and then go ahead with the design. So I'll close this dialog box. And I can go behind again in the pre-processing mode by clicking over here and make final changes to our model. After doing all these changes, I can go ahead. So this is about MIDAS Gen. Now let me go to the next software solution, that is MIDAS Design Plus. Tools, and directly open up the next software solution, that is MIDAS Design Plus, by clicking on this icon. I'll open up a new file. So here we have got design options. We have to select the codes. So firstly we will select the code. I want to perform the design as per ACI 318 but into metric system. So I'll select ACI 318M14. I'll click on apply. The software will automatically close the dialog box. Then the rebar code over here is ASTM. I can select as BSEN. Then I want to perform footing design. So I want it to design by taking P12 to P16 diameter of bars into consideration. And these are the spacing lists. I'll click on apply. Further, I'll go to the preferences. I'm double clicking on all these options to open it. So in preferences, I can ask the software to change the section by clicking on design. I'll click on OK. The next part is about the unit system. So here is the US unit system, keeps in inches. So I can change this to SI unit.